at forces now. So forces, there are many forces and they all act on objects. And we can observe this by using a ramp and some toy cars. So all these forces, if they're equal and the balance, we call them balanced forces. If they're different, slightly different, then we say they're unbalanced. If an object's moving and the forces are balanced, then the object continues to move in that direction at the same speed. If one of the forces or several forces change on the object that's moving, it may well change speed or change direction. And we can observe this using this ramp. So here we've got a car, a stopwatch, and this ramp is exactly 1 metre in length, and that makes it easier to measure because the car will move quite quickly, and so it's difficult to actually know when it's made a metre. But we know that by the end of this ramp it will be 1 metre. I'll measure the time in seconds, and then we could calculate the speed in metres per second. So let's give it a try. The difficulty is that you might need 2 people to do this investigation. One to set the car going and one to work the stopwatch, because human error will definitely get in the way of this investigation, so we would have to repeat it several times. So here we go. Put the car at the top of the ramp so we know that it's travelled exactly 1 metre. Don't push it because we're using gravity to get the car rolling, and let's just see how fast it goes. There we are. So it went over a little bit of an angle, so there must have been another force acting on that. So let's just reset this and we'll try again. So it's just letting it go. There we go, 1.25 seconds. So we've had 2 goes at that, and both times they were round about just over a second. There is another force that acts on objects, and you know this if you look at the bottom of your trainers or your boots, they'll look different than at the bottom of a flip-flop, and that's because of friction. Friction on rough surfaces acts between 2 surfaces. You know this, if you rub your hands together, you can feel the effect of the force of friction. So now we'll slightly change the ramp by adding a different surface. So here we've got some sandpaper that's quite rough. It's not the really smooth type, the glass finish type. And I'm just going to tuck the ends in because the weight of the ramp will hold it in place, and then just smooth it down so that there isn't anything else getting in the way of your moving car. And again, stopwatch, the same car. If you don't use the same car, then it's not a fair test. So we're just putting it at the top, we're not pushing, we're just letting go, and at the same time starting the stopwatch. So let's see how it goes this time. Wow, just over 2 seconds. So this surface definitely made a difference to the speed that this car's travelling. Let's just make sure we've not done anything wrong, and we'll try that again. So we'll reset the stopwatch, we're just letting go to just over 2.5 seconds that time. So would you say that this surface changes the forces that are acting on that same car on the same ramp at the same angle? And the answer, I hope, would be yes. If you haven't got a stopwatch, you don't need one. You can actually visually see the difference between the speed when friction is increased on this rough surface. And friction's used, it does have uses. It stops you sliding on ice, it stops you slipping on a wet and slippery surface, and it also helps vehicles to control their speed and stop at the bus stop so it doesn't leave you behind.